in this video, we're going to look more into the periodic phenomena. So if we consider this Ferris wheel, we get on here, we get on, and we go around, and we go around, and we go around. We can actually graph this. So if we look at X, we got Y, I want to use X as our principal axis here. It's going to be like ground level. So we get on, we go up, we go down, we come back down, we get up, and we go back down. Now, as you can see, we got on here, one full revolution there. So we've gone up, back down. Sorry, our principal axis is here, not the ground. X is our ground. Now, if we want to know the distance around that, we know the circumference of a circle is 2 pi r. So we'll use for this to make it easy, we make the radius 1 to help us. So circumference equals 2 pi. So one full revolution is 2 pi. So 2 pi is the equivalent of 360 degrees. So if we did, for example, a quarter of a turn, so we did a quarter of a turn, so a quarter of 2 pi, well, that's pi on 2. Now, we know a quarter of a turn is 90 degrees. So pi on 2 is equivalent of 90 degrees. So that's degrees, that's what we call radians. So if we did half a turn, so half of 2 pi, well, that equals pi. And we know that's 180 degrees. Now, if we went 3/4 the way around, so 3/4 of 2 pi, well, that's 3 pi on 2, and that's the equivalent of 270 degrees. So that's our distance. So when we talk about circumference is 2 pi, that's how far it is around the outside, or the distance the person has traveled on the Ferris wheel. It's a circle. So if they've traveled a quarter of the way around the Ferris wheel, they've traveled pi over 2. And we leave it in that form of pi over 2. We don't convert that. And we just leave it like that. And that's how we convert. We use this to convert degrees into radians. We can use this to help us find degrees or radians depending on the situation. So if we were asked to convert pi over 4 into degrees, well, we look here. We've got 0 or 2 pi's, one full revolution. We've got pi on 2. We've got pi. We've got 3 pi on 2, 3/4 of the way. Well, pi on 4 would go here, because half of pi on 2 equals pi on 4. Now, pi on 2 is 90 degrees. So half of 90 degrees is 45 degrees. Now, what we have to get used to is that we go anti-clockwise. That's positive. If we go clockwise, it's negative. So if you had negative pi on 4, that could be either negative 45 degrees, okay, because that'd be down here, or 360, take 45 degrees, okay, and that is 315 degrees. All right, so you got to make sure when you do questions, you read them. All right, And we can also use this to go backwards as well. If we were asked to find out the distance, the equivalent distance, if it went, for example, the Ferris wheel went around like 120 degrees. Now, that's 120 out of 360. Now, this will look familiar. Times 2 pi, we're leaving it as radius 1. Because that is the arc length formula that you would have seen back in years 8 or 9. 120 over 360, that's a third of 2 pi. Well, that equals 2 pi on 3. So 120 degrees is the equivalent of 2 pi on 3. So if we looked at 30 degrees, well, it's 30 over 360 times 2 pi. 30 over 360, that's, well, 1 over 12. That's 1 over 6. So that's pi on 6 radians. So that's the distance it's traveled. So if it's gone 30 degrees from its starting point, it's gone pi on 6 when it comes to radians in its distance.